Hi, welcome back. Today I am going to show you a project called deepfake detection for video and as well as for images. So the result that you can see here, when we upload in a video, it will be taking the frames and it will be detecting whether that video is deepfake video or deepfake image. So this is where our web applications you can see here. So even you can upload image as well as you can upload video also. There is a different interface for both of them. So this is our application and we have so many other features within it. How to test the image, how to test the video, everything we'll discuss. So before moving further, we'll discuss about how actually we built it and based on what papers we have built it, how our project is very much unique than what is existing now, and why we are getting far more better result than the existing papers. So what existing papers are already proposed and they implemented it, everything will be discussed step by step. So we're going to discuss everything in depth and then finally we'll see how we coded our models and how accurately we are getting the things and how we can test it as in a web application by integrating all of them here. So first you can see here, this is the one paper and this is the another one, like two IEEE papers we are referring. So what are all the things this paper are containing? It will be available here. Even you will be giving you the IEEE papers. We have those papers with us. Okay, both the papers we have. Okay. So this is done with help of deep neural networks and this is done with help of machine learning algorithms. So two different approaches how the existing papers are doing. So that we researched and we made it as a proper documentation, so which you can understand very much easily. So any paper when you open, mainly you need to check their methodology, what they are using, what models they are using. Okay, for example, what CNN models they are using, what RNN models they are using, and if they are using any GAN models, generative artificial neural networks, so that we are checking here. Okay, so this paper is speaking about almost all the possible CNN, RNN as well as GANs, and we'll see which one they are implementing, proposed architecture. So what are all the things are there in this paper? Okay, that is being mentioned. So for that what we do is we're going to, so there are steps mentioned here in the paper. Can you see that? Data collection, from where they got the data set. Okay, from what are the pre-processing they done. Actually they are not mentioning too much about the pre-processing. It shows that they are neglecting the pre-processing techniques and they are concentrating on feature extractions. So for the feature extraction they are going with ResNet 50. Okay, and they are building the classification model and what are the layers are there within them. So all these pooling layers, okay, convolution layers, dropout, dense, these are different layers. Okay, it is nothing new. They are type of layers, RCNN filters that we have. And one of the model they are speaking about is LSTM. Okay, long short term memory. This is one of the model where LSTM and RNs are sequential based memories, whereas CNN is frame wise. Okay, so where these things will be used, in which manner they will be used, we'll discuss. And they are mentioning like they are getting around 87.48% accuracy. The same thing we have mentioned here. Okay, so what dataset they are using, celebdf and phase forensics dataset they are using. And when it comes to pre-processing, they are not mentioning too much about it. Okay, they are just saying, okay, we are normalizing, we are doing video frame extraction, we need to do video frame extraction. Okay, there is nothing new here, nothing special is there. And when it comes to model architecture, they are going with ResNet 50 as well as LSTM. As they mentioned there, we have took it and we have made it as a proper documentation of what is existing. And then you can see system architecture flow, nothing but that only. They are using two models and they are getting around 84.74 for 20 epochs and 87.48 for 40 epochs. And this is the reality. When you increase the epochs, there is a high possibility to get more accuracy. Even this paper is not giving us the parameters like classification reports, how much you are getting as a testing accuracy, what is the validation accuracy. Nothing is given, only they are mentioning accuracy. We need to think about it. What accuracy is that a training accuracy? Is this testing? Is this a validation? What is that? So which is not clear. And the second paper that we are seeing here, this one, this is built with help of a machine learning models. This paper speaks about machine learning. So they are taking image data, video data, and they are processing them in such a manner it should be handled with help of machine learning model. So for that purpose, what they are doing, what this existing paper is doing for that. So if you go to methodology, you will get it. Data pre-processing features. Actually, what are all the data sets used in this paper is given. These are different data sets available. So they are taking up around 200-400 videos. Even we'll check. Okay, actually almost we are taking almost the same data set which this paper is taking, but we are going with our own methodology which is better than the existing system. And you may ask me a question, how can I say better? Because I have a numbers to prove it. I'm getting best accuracy, for better accuracy than the existing system, whatever you seeing here. So when they are working with machine learning, they need in combination of machine learning as well as deep learning. So in this model case also, they are taking deep learning for feature extraction, and machine learning models they are taking for classification purpose. You can see what are all the things they are getting for different data sets: FF plus, DFDC, CelebDF, VDFD. These are all different type of deep fake video data sets available. And you can see all those parameters they are providing. And finally you will see, okay, last one. What are the different models and how much accuracy they are getting? You can see SVM, random forest. Okay, so here they are trying to mention for each different data sets what are the values. Same thing, they even made it as a table for each model. Okay, which model? Random forest. What is the precision? What is the accuracy? What is the F1 score? Okay, so everything is mentioned here. Precision, recall, F1 score, everything is mentioned as a table. So almost they are getting nearly 199, near to that. So all these ROC curves are there, AUC curves are there. AUC curves of all the machine learning models, whatever they built for different data sets they tried. So they are going with in combination of deep learning as well as machine learning. So deep learning for feature extraction, machine learning for model building. So now the same thing we are presenting it as a documentation. So the dataset used, multiple dataset they are using. For each different dataset they are building different models to cross verify. Phase forensic is there, FF++ and DFDC. Actually this is the main dataset. This is very important dataset. This is very good dataset also, because this is a challenge dataset from source. Okay, so it is a challenge dataset. It is a Kaggle challenge dataset. Okay, so with this a bit complex than the remaining datasets. And CelebDF dataset is there, VDFD datasets is there. And when it comes to face extraction, they are using dlib to extract the face feature from the video. And then they are doing like feature extraction. They want to manually extract the features from the face. So because they are going with machine learning as a classification model, so in this paper they are concentrating mainly on HOZ, HTF, CH and HM. It means they are mainly extracting all the features and their color features and their size, okay, dimensions, like that. Okay, all these will give those values only indirectly. And all the feature extraction thing will be extracted, and then multiple machine learning models are used here. SVM, random forest, ERT, decision tree. Okay, MLP is there, SGB. Okay, stochastic gradient boosting algorithm as k nearest neighbor. And what are the evaluation matrix they are getting out of this? Accuracy, precision, recall, F1 and AUC curves. So when you check, they are mentioning 99.78 for face forensic, 99.6 nearly for DFDC. For celeb DF, they are getting 99.4% accuracy for VDFD and MLP. And yeah, okay, so this is about the second paper. So now what we do is, what we are proposing, what is our proposed methodology. So how our proposed methodology is better than the remaining, I will tell you as a diagrammatical explanation. Once I explain it, I will come back and I will show you the demo. Okay, now you can see here. So these papers I already shown you. These are IEEE papers, two IEEE papers. If you approach us, we will provide you IEEE papers as well as synopsis. Once go through them, and if you are okay with our project, you can take project from us. You can call to the number given below, or you can just WhatsApp us, or you can just visit to our website to contact us. Okay, so according to your requirement, we can even do the manipulations or changes, and we can provide it to you. You can just discuss with our team. Okay, they will guide you further. Now let me okay, this is a complete application code that we built for the deepfake one. So this is a code that we built using the datasets. Which dataset we are using, I will tell you. You can see here our main dataset is this deepfake challenge dataset, which is around 4.4 GB, which contains multiple videos. Now from each video we are going to extract the frames and we are going to train our model. So that dataset will be available here. This is a deepfake dataset which contains many number of images within it, which contains both real as well as fake images within it. So using these datasets we are going to train our model. How we are training our model, that is needed. So what are all the steps that we are using? I will be mentioning one by one, and why they are very important, we'll see. And before moving further, I will show you the accuracy of the models. Okay. So this is using actually lot of data. We are getting this from each video. We are extracting so many frames, and then we are getting this testing accuracy, training accuracy, as well as classification report. And one more special thing with our project is classification report as well as explainable AI. Like this result, explainable AI is very unique with us. So let us discuss what is actually happening here. For example, and we have built another model which accuracy is nearly 100%. That also I will show you. Okay, so now in our case what we'll do is, for example, here there is a video. So our data set is prepared in such a manner, from each video the frames are taken away. Okay, multiple images, and from that also using dlib only face is cropped. So as you see in that video. Okay, now our data set is only face images. Now using this, what are all the unique things that we are taking up is, first thing is augmentation. Augmentation is a technology or the method. Using this we can increase our existing data sets to very large size. In the augmentation, what we do is, for example, if we have one image, we will make sure it will be increased to many number of images. Initially in our case for fake we have around 8,000 images, whereas for real we have very less number of images, around 2,000 images. We needed to balance it. To balance these images we went with augmentation. So there we try to create around 16,000 images for both the classes, so which is very huge. 16,000 images. So after creating so much of data, then we go and apply sequence of pre-processing techniques like Gaussian noise blur to remove the blur or to remove the noises, then enhance the image using multiple approaches like CLAHE and histogram, and then we're gonna apply Canny detection, then we're gonna highlight the images, then we're gonna highlight region of interest. Okay, then we're gonna mainly take that and overlap on our original images. So here we do augmentation, image pre-processing. In the end, how results will look is, can you see, maybe as a human we can't identify that, but for our models, for our computer, for our GPUs, for our code, it is very easy to understand like these images with highlighted region of interest on the face, curves, changes, okay, small variation on the face. It will try to understand them, understand the variations very easily when you try to highlight the region of interest. So that's what we are doing. So once we highlight the region of interest, then we're going to do we're going to apply multiple models, few transfer learning models. I will tell you, one among them is EfficientNet model. If you train it for a lot more number of images with lot more number of epochs, it will be getting very good results than what it is giving. We are getting around nearly 100%, nearly 100% of accuracy for DFDV datasets. Okay, and for this challenge dataset we are getting more than 90%, 97, 98% for this dataset. For DFDV dataset we are getting nearly 100% testing and validation accuracy also. So EfficientNet, and then ResNet 50, and then we can even go with the DenseNet. Okay, and one more thing we are doing is we are going to try with hybridization of those models. Two deep learning models, two transfer learning models, two CNN models, we are going to hybrid them. Okay, once we hybrid and we train them, they will be little bit better, and these hybrid models will try to reduce the overfit and underfit mainly. So if whenever there is a problem of overfit underfit, we can try with hybrid models, but you need to train for lot more number of epochs when we try with hybrid models. So then once we build our deep learning model, okay, we are going to integrate it as a web application with multiple technologies like Flask and HTML, CSS, JavaScript, okay, which will become complete front end like this. So now this is a complete web application which is built, and we integrated our models, image model as well as video models in the backend. Of course, as you can see here, these are the codes that you can see, all the models, and this app.py and our model prediction models. Okay, so whatever we train, we need to load it here. We need to load our model, whatever the model we built, we need to load. So then we need to take the images, single images. If you upload, it need to take the single image, it need to pre-process, then it need to predict, and it need to return back whether that was fake or real. All those things will be updated. So let me show you how to detect it on video. So let me upload this and let me wait for that. And where these things can be used, how in real time also it can be changed to some other thing. For example, the same deep fake video and image detection can be integrated into social medias, where if someone is uploading any video or images, at that time itself you decide what is that, is it a fake or is it real. If it is fake, reject it, don't allow to upload and then try to do something whatever. No need. While upload, just reject it. You don't need to think after uploading 2 months, 3 months. Nowadays some APIs or some algorithms are like that, they will take a lot of time. Okay, I don't know why they will take that much time. They can decide it at the entry point. Okay, they will take a lot of time and they come up with, okay, this happened, that happened. Why you take that much time? Yeah? Integrate it in real time and you get whether there is a fake or real. So that also we have built a project. In the next session I will be coming up with that social media, how we can integrate deepfake video and image detection, and how we can filter out if someone is trying to upload any deepfake image or video, how we can reject that video. Also I'm going to come up in the next session. Okay, the complete project demo as you are seeing now. So here it will take some time because it need to calculate frame by frame. Okay, so once all the frames are being calculated, it will try to give us the result whether that video is fake or real. And these processing things will almost be depend on your system capacities. Okay, here we concentrate more on the face part. Okay, so our main concentration is face. So here we are going to take, can you see, the face thing. Face thing is being selected here because face is our most important region, our region of interest. So whenever you upload any video, I will take frames frame by frame. Each frame I will detect a face. For each face I'm going to detect whether it is a fake or real. So based on that I'm going to give a result here. So our project is mainly deciding whether the given video or given image is fake or real with the help of the model that we built, like EfficientNet model, ResNet model, DenseNet model, hybrid of EfficientNet, ResNet, hybrid of EfficientNet and DenseNet. So whatever we built, we have trained, we have tested, we got our accuracies, we got our loss, we got our classification report. So we have proposed our methodology, we have pre-processed images better than the existing. We concentrated mainly on balancing the dataset. We concentrated mainly on robusting the existing data. We are increasing the dataset that exists so that we can train our model efficiently to get a better result. That's what we are trying to get here. So this is a complete project. If you just approach us, our team will be helping you with initial things like synopsis as well as the explanation what we are doing. After that you can decide whether you want to take a service from our side. Then we can move further and we'll help you the complete service of a documentation, coding, and even for the discussion. Okay, if you are having your own idea, if you are having your own methodology, you can mention to us. We can even build customized project for you. So we are open to almost everything. Okay, whatever you have, your idea is always accepted, and according to your idea we're going to build the project. Okay, so this is all about today's project. We'll see in the next session with a better project. Thank you. Don't forget to subscribe and like our channel.